Hello everyone! In this video we will continue to examine topic 2.1 motion, and in particular we will introduce the concepts of speed and velocity. In motion, one of the incredibly important questions to ask is how fast are things moving? And the answer to that question can come in two forms. There are two sort of sensible answers to that question. One is the velocity, which is defined as the rate of change of position with respect to time. Notice how the change of position there, right, is the displacement. So how quickly is the position changing with respect to time? The unit is meters per second, and velocity is a vector. So -2 meters per second, or 10 kilometers per hour northeast, or 1.5 meters per second at 30 degrees from the east. These are all ways of quoting the velocity, which includes the direction. And speed is a word we use to mean the magnitude of the velocity. So in this case, it would be simply 2 meters per second, 10 kilometers per hour, and 1.5 meters per second. Note that the speed is what is measured in your car by a speedometer. Notice the speedometer doesn't care what direction you're going in. It simply tells you the speed at that particular point in time. Notice that our symbol for velocity is v with a little vector hat, and our symbol for speed is v without the vector hat. So the magnitude of the velocity is the speed. And imagine you're having, you've got sort of two objects and they're moving. You might graph their motion like so. And in both cases, these two objects, both the red object and blue object, can have their position graphed versus time. And these two objects are moving at constant velocity. And you can find the velocity for either of these two objects by taking the slope of the position time graph. In calculus notation, v is defined to be ddt of x. So if we take the slope of either our blue line or our red line, it will give us some delta x over delta t, some displacement over a period of time. And that slope is higher for the blue object than it is for the red object. That indicates that the blue object has a larger speed. Okay, larger speed. The velocity is given by the sign of the slope. So if that slope is negative, then it is going in the negative direction. Notice that the slope itself, the sign of the slope, is giving you the direction of the motion. Notice also that on this particular graph, at constant velocity, this simply is graphing a situation in which some object, the red object here, is starting at an initial position that is further along this axis, the position axis, than the blue object. But the blue object is moving faster, and so at some point they collide, or perhaps the blue object passes the red object and continues on. This kind of graph is one to be familiar with, and we can see that the velocity of the blue object is greater than the velocity of the red object here, and for the same delta t, the delta x for blue is bigger than the delta x for red, meaning the displacement in the same amount of time is larger. That's simply what it means to have a larger constant velocity. Notice that each of these lines can be graphed in the form of a particular equation. You can write, in fact, the position as a function of time as a linear equation. Each of these lines has as a y-intercept the initial position, and as a slope, the velocity. And then time is plotted on what is traditionally known as the x-axis. So the position as a function of time is equal to the initial position plus the velocity times the time. This is true for all motion at constant velocity. Notice that at constant velocity, the velocity is simply equal to the slope of this line, that is the displacement divided by the time. The speed at constant velocity would be equal to not the total displacement over the total time, but the total distance over the total time. Notice there are a couple of worked examples built into the notes here, and you can take a look through them. There is a representation known as a motion map, which I might use occasionally moving forward, and you can consider a motion map to be a representation of the object at different points in time at equal intervals. So the object is first here, and then here, and here, and here, and here. That displacement is shown as the gap between those points, and the velocity is shown with a single vector starting at that point. The final position after an interval is equal to the initial position plus the displacement between them.